Good morning everyone. This is series of lecture for T.Y.B.Sc Analytical Chemistry students semester 6. The course is CH611A and the chapter we are going to study is chapter number 6, flame emission spectroscopy. Now in this topic or in this lecture we are going to study measurement of emission of atomic species. Now atomic species are nothing but these are the charged, either positively charged or negatively charged or chargeless, that means neutral species. Now its emission takes place. Now its emission takes place from the flame. Now in the flame emission spectroscopy, the instrument used is flame photometry, and in that flame photometry we have already seen about the introduction, some part of the principle. Now it's a working, type of the burner unit, premix type of burner, total consumption burner. Now premix type of burner is also called as a laminar flow burner. Now the instrumentation consists of mirror or reflector, wavelength isolation system, diffraction grating or prism, and detector, that is a photomultiplier tube, and finally readout system. Now this is all about involved in the some part associated with the flame emission spectroscopy or theory associated with the flame emission spectroscopy chapter. Now we will focus on the how the measurement of emission of atomic species is carried out. That means the emitted atomic species, how its intensity is measured in flame photometry. So this specifically this lecture gives the information about this topic. Now here in that principle we have already learned about the what are the exact process takes place in the flame photometry. Now here the analyte is dissolved. Here the first point is that the analyte is dissolved in a suitable solvent to make its solution. Means here the sample is dissolved in a suitable solvent to make its solution. Now generally if we have to analyze the calcium, then we dissolve the calcium in calcium, it's a solvent like calcium chloride. So the analyte is dissolved in a suitable solvent to make its solution. We know that solution is nothing but the combination of analyte plus solvent. So analyte is nothing but it is a sample under consideration or under study. So analyte is defined as it is the sample which is under consideration for the study. So analyte is dissolved in a suitable solvent to make its solution. The resulting solution is aspirated to the flame by dipping a capillary into it. So here the resulting solution, whatever the analyte is dissolved into the solvent to whichever the solution is prepared, that resulting solution is aspirated into the flame by dipping a capillary into it. Now here the solution runs into a capillary by a reduced pressure. So here reduced pressure is very important, because in the capillary reduced pressure is created and that capillary is inserted into the solution so that the solution is lifted up and it will reach to the flame. The series of events such as breaking the sample solution into tiny droplets followed by evaporation to form the residue, followed by formation of atoms, that means atomization takes place, and the burner unit itself carries out the process of atomization. Now the second point, it consists of here when the sample solution goes to the flame, at that time into the flame or into the burner into the flame, number of events takes place, and that series of events is nothing but the first, the sample solution goes into tiny droplets, and then tiny droplets goes into the residue, and this residue is then reduced to the atoms. So these are the steps that come under the series of events. Now the burner unit itself carries out the process of atomization. So here burner is used for the atomization process. Atomization process is nothing but the here formation of atoms, that is the formation of neutral atoms. Sometimes charged species, that is positive or negative species, is also formed, but we are basically consider here neutral atoms are excited, and these excited atoms are unstable, and that it will come into the ground state, and finally it emits the excited atoms emits the radiation, that is emitted intensity is measured by the detector. And the third point, now we will focus on the third point. When only distilled water is aspirated to the flame, no atoms of the metallic elements are present. So third point is very important, because how the measurement of the emitted intensity is measured, or emitted intensity is measured of atomic species, that is elaborated here in the third point. When only distilled water, that is nothing but the solvent used in the flame photometry, when only distilled water is aspirated to the flame, no atoms of the metallic elements are present. So when distilled water is aspirated into the flame, at that time no atoms goes into the flame, because distilled water does not contain any type of the analyte. Hence no excited and emitted emission is observed. Hence no excitation and emission is observed. So if there is no atom, there will be no excitation, or there will be no excitation, there will be no emission, and therefore no light falls on the detector. So detector does not recognize any type of light unless and until there should be an atom should be present. Therefore flame photometer is calibrated against distilled water. So what is the purpose of distilled water here? Flame photometer is the distilled water is used as a calibration purpose in flame photometer or flame photometry. The reading comes to 0. So whenever the distilled water is employed into the flame, at that time the reading is 0, because there is no atoms is present. At that time, if no atoms is present, there will be no intensity, no intensity, and therefore no reading is observed. Therefore zero reading is observed here. Now emission intensity of any solution containing analyte is easily measured with great accuracy. If the analyte contains any atoms, if the distilled water contains analyte having specific atoms, at that time there should be the emitted intensity is observed by the detector, and that should be measured accurately. So this is all about the measurement of emission of atomic species, how the measurement of emitted intensity is carried out by the flame photometry or flame photometer. So these are the 3 points which gives the information about this topic. With this content I conclude this lecture. Thank you very much for your patience listening.